I'm Robert Bruce Thompson, and this is the Home Scientist video series. In this segment, we'll use a common kitchen spice to detect the element boron at very low levels. The spice is turmeric, and its primary active ingredient is a polyphenol called curcumin, which gives turmeric its yellow color. Curcumin has been used for 100 years as a test for boron, with which it forms an intense red complex called rosocyanine. The curcumin test is still used by environmental scientists to test water and soil specimens for boron. The test is fast, cheap, and sensitive enough to detect boron at sub-part per million levels, nearly as sensitive as instrumental analysis. Let's get started. I've never done this test before today, so we'll all be seeing the results for the first time. I've made up a standard solution that contains 1 gram of boron per liter, which is 0.1% or 1 part per thousand or 1,000 parts per million boron. I did that by dissolving 0.88 grams of sodium tetraborate decahydrate in some water and making up the solution to 100 milliliters in a volumetric flask. Boron makes up 11.34% of borax by mass, so that 0.88 grams of borax translates to 0.1 gram of boron per 100 milliliters, or 1 gram per liter. I've transferred 2 milliliters of the 1,000 parts per million boron solution to this first well in a 3x3 matrix on my reaction plate. To each of these other 8 wells, I've transferred 1 milliliter of water. I'm going to do a serial dilution by withdrawing 1 milliliter of the 1,000 parts per million solution and transferring it to the second well. I'll draw it up into the pipette and expel it several times to make sure the solution is mixed. So at this point, we have a 1,000 parts per million solution in the first well, a 500 part per million solution in the second well. I'll withdraw 1 milliliter of that and transfer it to the third well, which becomes a 250 part per million solution. Okay, I've now completed the serial dilution. The first well is 1,000 parts per million, 500 parts per million, 250 parts per million, 125 parts per million, 62.5 parts per million, about 31 parts per million, about 15 parts per million, and about 7 parts per million. Now this last well has 2 milliliters in it rather than 1 milliliter in the other wells, so I'm going to withdraw 1 milliliter of the solution and dispose of it. The center well contains only 1 milliliter of plain water. We'll use that as our control well to compare against the colors that we produce in the other wells. I made up my curcumin reagent by adding a pinch of turmeric powder to a few milliliters of drugstore 70% ethanol. So to begin, I'm going to add 3 drops to the center well. And as you can see, we get a nice intense yellow color. All right, let's test the most concentrated, the 1,000 part per million boron well. We'll add 1, 2, 3. As you can see, you get an immediate, intense reaction. Well, I've dripped it outside the well. Let's add it to the second well. 1, 2, 3. Still a very intense red reaction at 500 parts per million. And again, very intense at 250 parts per million. And at 125. And at 62.5. For a real analysis, we'd use a spectrophotometer to measure absorption at 540 nanometers, which is the absorption peak of rosocyanine. Boron reacts quantitatively with curcumin to form rosocyanine, so the concentration of boron present can be determined directly from how much light the specimen absorbs at 540 nanometers. For our purposes, we're just using our Mark I eyeball to detect the red color of the rosocyanine. At high concentrations, we get an immediate, intense red coloration, as you can see in the first 2 wells. And then gradually, as the concentration of the boron decreases, the color shifts more towards an orangish rather than a deep red color. But as you can see, comparing the center well, which is plain water, even with the 7 part per million boron solution, it has a rather intense orange. We could probably take this well down into the sub 1 part per million and still show a noticeable color change. As we've seen, the curcumin test is a much more sensitive and specific test for boron than the traditional methanol flame test. If you want to try a real-world test, collect some water and soil specimens. The water specimens can be tested as is. For soil, soak 100 grams of the soil in 100 milliliters of water overnight. Decant off the liquid through a filter paper, evaporate the liquid down to 5 or 10 milliliters, and use that as your test specimen. You may not find detectable levels of boron in any of your samples, but boric acid is a common insecticide, so soil from flower beds is more likely to test positive. Please subscribe, rate, and comment.